Hey y'all, this is 2-1, we're transforming parabolas. I've already taken a little bit of notes. A parabola is a U-shaped graph. So it's anything that looks like this. And you should hopefully remember these from Algebra 1. In Algebra 1 we did parabolas. We also called them quadratics because a parabola is the graph of a quadratic. But we're going to go over that again today because I know it's been 2 years and a pandemic, which sounds like 3 more years. So I'm going to catch that and then make a big noise. I'm going to pause this so I can draw a graph. So you can pause it after I'm done doing the graph. Okay, pause it and catch up. So the parent function is y equals x squared, or f of x equals x squared, because we're in function land. And here's my graph. So it's 0, 0, and it's going to be 1, 1, and negative 1, 1, and then 2, 4, and negative 2, 4. Okay, so again, those points were 0, 0, 1, 1, 2, 4, and then also negative 1, 1, and negative 2, 4. When I say these points, I don't usually out loud say the negative ones because they're kind of implied from the symmetry here. But this is how this looks. It's just so fuzzy. I don't know what's wrong with my camera. It's so fuzzy. Don't worry, there's a picture of this online, so you can catch up that way too. So this is my parabola, and then those are my points. So what I'm going to do is I'm going to show you a couple of examples of graphing parabolas. Let me set up so I'm a little bit further. Hey, I fixed the blurriness. Let's go. Okay, so we're going to graph parabolas, and we're also going to describe the transformation. So here's my first example. We're going to do f of x equals 2 times x minus 1 squared plus 3. I don't know. I'm making this up, by the way, because I can do any numbers I want. So for the description, this is just like last notes. This is the same. So this 2 right here is a vertical stretch of 2. This minus 1 is going to be shifted to the right one. Why did I have such a hard time with that? It's backwards. That's all I have to remember. Right 1, and then this 3 means we're going up 3. So that's my that's what I'm going to be doing. I'm going to pause this so I can draw a graph really quick, so I don't want to waste time on that, but then you can pause it after that. Okay, I drew a graph. I wanted extra space up here because I know I have to stretch this out by a factor of 2, and I already sketched in my parent function. It's so glitchy. Computer, why are you so glitchy? I already sketched out my parent function. So I sketched out my parent function by going 0, 0, 1, 1, 2, 4. Can I just turn off my face? Is that a thing? No, I did not make that an option. Oh, I just went through all that with you too. Don't judge me. So what we're going to do is we're going to take this and we're going to first of all do a vertical stretch and then move it right and up. Okay, so a vertical stretch looks like I'm going to take my graph and every height I'm going to double it. So this is currently 1 high, it's going to be 2 high instead. This is currently 4 high, it's going to be 8 high instead. And then same thing over here, 2 high, 8 high. So this is my stretched out version. I don't need to sketch this part, but I kind of want to, so I can show you what it looks like. It's been stretched. It's going whoop. Let me show you better. It's going whoop. Okay. So then everything I do, I'm going to move all of these points to the right by 1 and up by 3. So I'm going to start with my vertex. Right 1, right 1, up 3. This one, right 1, up 3. This one, right 1, up 3. And then this one, right 1 up 3. And this one, right 1 up 3. And then I just connect my dots. We're gonna pause for the train. Hey, look, I just put it all together while I was waiting for the train to go by. Okay, this was our option number 1 of how to graph this. This is using method number 1. I'm not sure what to call this. We just transformed it. So we'll call it the transformation method if you want to talk to me about it later. So we did a vertical stretch of 2, we doubled all heights, and then we went right 1 and up 3. Now, let me show you a different method. So in a different method, we find the vertex, which is the starting point. It's HK. And you might remember this from Algebra 1. I'm so sorry about my cat in the background. So my vertex is +1, +3. So our vertex here is 1, 3, with a stretch. Wow. Hold on. Man, with a stretch of 2. So one thing we can do for the stretch of 2 is we can take our y values of our points and multiply all the y values by 2. So what that looks like is I have my y values. What that looks like is I have my 0, 0, 1, 1, 2, 4. Technically the next one's 3, 9 because it's all the squares. And I keep my x's the same, but I do all my y's times 2. So I get 0, 0, 1, 2, 2, 8. And what that means is that I'm gonna put the vertex down first. Am I running out of space for this? Absolutely, hold on. Okay, I'm cheating just a little bit and I have some scratch paper here. And it's perfectly shaped in graph form, which makes me really happy. But if you don't have this, you can use the next page. I don't like to use 2 pages for my notes, or you can add a sticky note. The best thing you can do when you're when you want more space is just add a sticky note on top of it. So what I'm gonna do is I'm gonna place my vertex 1, 3, and then from there, this is my vertex. This is where 0, 0 is on this graph. So from there, I'm gonna go 0, 0, which doesn't matter. I'm gonna go over 1 up 2 and negatives. And I'm gonna go over 2 up 8. Oof, 1, 2, 3, 4, 5, 6. We're gonna start that all over again. Hey, it's gonna be up off the graph and that's okay. I'm gonna actually do it right when I take my notes picture, but that's gonna be the graph and it's the same graph. These are the same. I just have a better scale on this one. So it depends on how you want to do this, but either way works. So you can either, first of all, vertically stretch it and then move it right and up, or you can place the starting point and then stretch the starting point out by multiplying by the y or by that a value. I don't know if that helps you. I'm really hoping that helps you. If it doesn't, please tell me. I will absolutely give you more examples. I will do more practice problems. I'll do them on a separate piece of paper. I have a whole notebook just for separate practice problems. So please let me know if you need more. I will do this for you. No problem. No judgment either. So that's the end of our notes for today. I hope that that helps you complete your homework for tonight. And if it doesn't, please tell me. But we have to say, so basically you have to tell me what the transformations are. These are the transformations. And then you have to graph it at some point. If you do the Desmos, you have to graph it on the computer, and if you do in paper, you want to do it on the paper, but either way. Okay, that's all she wrote. Bye!